Okay, so today's topic is software test design techniques. So now we are going to discuss software test design techniques. So what is the use of software design techniques? So where exactly we use these techniques? So normally when you perform a testing, right, we need some kind of test data. So what is test data? That is data which is used for testing. So for example, I have a login screen. So I want to test the login functionality. So to test the login functionality, we have to prepare some test data like valid inputs and invalid inputs to perform positive testing and negative testing. And we don't test login only with the valid credentials. So valid username, valid password, which will successfully log in. But apart from this, we have to check a different type of data like a valid username, like username contains the spaces, username contains the special characters, username contains the numbers, or username contains a combination of numbers and alphabets. So different type of data we have to prepare, and then we'll conduct the testing. So what test design technique will be used? So the test design techniques will be used to prepare the test data. Okay, so let me write small notes here. test de- we can say test design techniques or test data or test case design techniques, whatever it is. So the test design techniques will be used to prepare data for testing, for testing. And that is a one thing. And the second usage is sometimes to test some functionality we have to prepare so much of data. So instead of preparing the so much of data, we can minimize the data and we can improve the coverage. There are two things are important. The first thing is data and the second part is a coverage. So what is data means? The data means which is used for testing. And what is coverage means? Whatever data we prepared, with that data, we should able to cover all the scenarios of testing. So for example, again, take the login functionality. So valid username and valid password, or invalid username, invalid password, or valid username, invalid password. So different combinations of data we have to prepare. And why you're preparing the combinations of data? Because we have to cover all the scenarios, all the testing scenarios. So that is called as a coverage. Okay. So the main usage of test design techniques is to prepare the test data, which will cover each and every area of the feature, which will cover the each and every area of the feature, every of the functionality we can cover. So that is the main intention of using test design techniques. So by using test design techniques, we prepare some test data which can cover each and everything of the functionality. So that is the main usage of test design techniques. And by using test design techniques, we can also reduce the data. With minimal data, we can cover everything. Okay. For example, I have a small, let us say, I have a simple or a small text box. Okay. So in this text box, I just want to enter age of the person. Okay. So my requirement is the age should be in the text box, allows age should be, let's say, 18 to 30 years. 18 to 30 years is my requirement. So in this particular requirement, how much data we have to prepare? Normally, how many inputs we need to test this? We have to test first 18, then 19, 20. Let's say from 18 to 30, all the numbers we have to test. And these are all valid inputs. And below 18, whatever numbers we have from 1 to 18 also we have to test. They are invalid data. You should not allow. And after 18, after 30, whatever numbers we have to test with all the numbers. These are all also input data, invalid data. So if I just look at the small requirement, there are huge data we have to test. Instead of testing all these kinds of data, we can just minimize the test data. We no need to go for all the numbers. By using testing techniques, we can reduce the data, but at the same time, we have to make sure everything is covered or not. Each and every corner scenario also tested or not with minimal data. And the test design techniques will be used there. So test design techniques will be used to reduce the data and more coverage. Okay. Test design techniques will be used to reduce the data and also which will increase the coverage. Now let me write the notes. It will basically reduce the data and more coverage. So these are the two advantages of test design techniques. But what are the test design techniques we have? So we have five types of techniques to design the test design techniques: equivalence class partitioning, boundary value analysis, decision table based testing, or we can say decision table, state transition, error guessing. So these are the five techniques we have. So these are called test design techniques. Very important in interview point of view also, and especially when you go for IHTQB certification examination, you will get a lot of questions on this topic. So listen carefully. So these are the five types of techniques we have. These are called test design techniques, or we can say test data design techniques. Okay, test data design techniques, or we can say test case design techniques. Anything is fine. And what is the use of test design techniques? We can reduce the data and also we can increase the coverage. Now let us discuss one by one. So there are five types. We have five test design techniques: equivalence class partitioning, this is also shortcut called as ECP, equivalence class partitioning; boundary value analysis, BVA; decision table testing; and state transition, error guessing. So these are the five techniques we have. So now let us discuss one by one. So let me share small presentation. Just a second. Okay. So now, yeah, these are the four techniques we have: equivalence class partitioning, boundary value analysis, decision table testing, and state transition, error guessing. So first let us start with equivalence class partitioning. So how we can use this technique? So here we have to mainly partition the data into various classes, and we can select the data according to class, then test it. So it reduces the number of test cases and saves a lot of time. So I'll give you one example how it will reduce the data and it will cover everything. So let us say this is my small text box I have, and I have to enter some value in it, and which will allow only digits, only numbers between 1 to 500. So I can enter only 1 to 500 values here, right? So if I don't use any test data technique, right, how we will test this with all combinations means we just try to enter from 1 to 500 numbers. So we'll test first one, we'll check whether it is allowing or not, then next 2, 3, 4, 5 till 500. So 1 to 500 numbers we have to enter and test whether it is allowing or not. So that is a normal test data. Okay. And instead of testing all the numbers, we can just use equivalence class partitioning technique or ECP technique, and we can reduce the data. And at the same time, we can cover everything. So we no need to miss anything here. With small set of data, we can cover each and everything, all the scenarios. Now let us see how we can use equivalence class partitioning technique to test this or to prepare the data. So if I just look at here, in equivalence class partitioning, what you will do is, as a first step, we will divide the entire data into multiple classes. Okay, or we can say partitioning, dividing or partitioning. So partitioning data into various classes. This is the first step we will do. So how we can partition the data? Let us say I have 1 to 500 are allowed. So before one, also we have to test some numbers because that is invalid data. It should not allow. And after 500 also, what are the numbers we have, that is also should be tested. It should not allow us, that is a negative data. So we should also include them. So we have to divide entire numbers into different classes, or we can partition in them. So in ECP we can say divide values into equivalence classes. Let's say minus 100 to 0 means these numbers are fall under below 0. Okay. And let us take one number from this, from minus 100 to 0, take any one number. Let's say I have taken minus 50, and when I add this value here, which is invalid value actually, so you should not allow. If minus 50 is not allowed, what does it mean? Whatever number we have given in this range, that should not allow. That will not allow, first of all. But we no need to verify with all the numbers. Just take one value between this range and check it whether it's working or not. So if it is not allowed means what? Whatever number fall under this bit in this range, which will not allow. With single value, we can test that. Similarly, 1 to 100, 1012 to 200, 2012 to 300. So we will divide entire data into multiple classes. These are called equivalence classes. So once you divided, now in each and every class, every group, we will take one value. Let's say from 1 to 100, let us take 30. Anything, any number you can take between 1 to 100. So if 30 is allowed means what? We will test 30 here. 30 is allowed means what? Which will allow all the numbers from 1 to 100. So just we are testing with one value. We no need to test with all the numbers 1 to 100. Just take one value from that class and then test it. Similarly, 1012 to 200, 2012 to 300, 3012 to 4, 401 to 500, 501 to 600. So after 500, we will take one more class because this fall under invalid data. So we should take one more class. So now in each and every class, we will pick one number. Any number you can take between that number. So here I have taken 160, which will fall under between 101 to 200. 250 again comes between 201 to 300 and so on. So from 501 to 600, I have taken 550. Actually, this is invalid data. This is invalid data because we need to also test the invalid area. So this is how we need to divide the entire data into different classes, and we'll choose one value from each class. And these values only we will test. So if I just look at here, this is the final data, which we are going to use for testing by using ECP technique. So what ECP technique has done here, ECP technique is covered everything. At the same time, it reduced the test data. So we no need to verify all the number from 1 to 500, not at all required. So we can simply divide the data into multiple classes, which is called as equivalence classes. And in each and every class, we'll pick some value randomly and verify that. Suppose from 102, 101 to 200, if one value is working fine means what? All the values will allowed from 101 to 200. But we no need to verify each number. So this is called as equivalence class partitioning technique. So if I don't use this technique, we have to use all the numbers. Every number we have to test. Again, which will take a lot of time also unnecessarily. And here, by using ECP technique, we can minimize the test data. At the same time, we can improve the coverage, test coverage. So that is a equivalence class partitioning technique. And now I'll show you one more example. All right, so now look at this. This is also equivalence class partitioning example. So here I have a small text box which will allow only alphabets, Alphabets means what? A to Z. Either it can be uppercase characters or lowercase characters. So how we can partitioning the data? So here only alphabets I'm saying. Only alphabets means we will partitioning the data like this. A to Z, uppercase letters, A to Z, small case, special characters, spaces, numbers. So this is the actual type of data we have. So now we have to create some test data. So by using A to Z uppercase characters, we will prepare some data like this. So from lowercase letters, we use some data like this. And this is uppercase and lowercase is covered. Now special characters are invalid, spaces also invalid, numbers also invalid. So special characters in the sense, these are the special characters. Spaces, space between the values, numbers. So we first classify the data and then we will prepare some data which is belongs to each and every classification. And this is actual test data which we can use it for testing. So this is equivalence class partitioning. So in equivalence class partitioning, our main intention is the value check. What the value we are providing is correct or not. Okay. So let me just write a small notes. So the first technique is equivalence class partitioning. here checking the value, or we can say simply we concentrate on value check, and we will classify the data into multiple partitions or multiple classes. Classify or divide or partition, any term you can use. Okay, so here we are checking the value, mainly value checking. So we classify or divide or partition the data into multiple classes, and then we will choose data from these classes. So that is equivalence class partitioning technique. This is one of the very important technique which we have to use while preparing the test data. Okay, and next one is boundary value analysis. The next technique is boundary value analysis. So in the boundary value analysis, we mainly focusing on the boundary of the values. Boundary of the values. In equivalence class partitioning, we mainly concentrate on the value. What is the value we are entering in the text field? And in the boundary value analysis, we will concentrate on the boundaries on the value. Mainly boundaries we will test. So I'll give you one example. So what is boundary value analysis? So we can call it a BVA technique. So BVA technique used to check the boundaries of the input. So for example, see this. Here I have a small text field called age. So here I want to, it will allow us to provide like 18 to 35. So the age between 18 to 35. This is my requirement. So normally how we will test it? In 18 to 35 means what? When I pass any value between 18 to 35, it should allow. That is all valid data. And also I should test with invalid data. For that, what I have to do? I have to enter all the values below 18, and also I have to enter all the values above 35. So they should not allow. So to cover the positive as well as negative input. So that is a normal way of testing. But in the boundary value analysis, we can reduce the data. At the same time, we can improve the coverage. But how we can use this technique, boundary value analysis? So in the boundary value analysis techniques, we will just test the only boundaries. We don't test all the values, only boundaries we will test. For example, so when I say 18 is a minimum value and 35 is a maximum value. Okay. So when I pass minimum value, it should allow. When I pass maximum value also, it should allow. And I will test only 6 parameters. Here I will test with only 6 values. I don't want to test all the values. For example, when I pass minimum value 18, it should allow. When I say minimum plus 1, that is 19. So it should also allow. And when I say minimum minus 1, which is 17, it should not allow. So what does that mean? Only 3 parameters I'm checking here. The minimum boundary. So when I say, when I pass minimum plus 1, 19, if it is working fine means what? Whatever numbers fall under this particular range should work. But we are not testing all the numbers. We are just testing only one value here. Okay, if it is working fine means what? All the numbers between this range will work. Similarly, when I say m minimum minus 1, which is 17, and which is not working means what? Whatever numbers are comes below this 18 will not work, will not allow. Because we have just tested only one value below the 18. If it is not working means what? All the numbers which comes between below the 18 will not allow. That is covered. And now this is minimum range, minimum boundaries. Now comes to the maximum. So max equal to 35, which will allow. And below the maximum number, just we will verify only one value. That is maximum minus 1, which will also allow. So here we are checking minimum plus 1, maximum minus 1. So if these two values are allowed means what? All the values will be allowed between this range. Now, maximum plus 1, and this is not valid. So which will not work. If this is not valid and it is not allowed, that means what? Whatever number comes after 35 will not allow. So we no need to verify all the values. This is the comes under boundary value analysis. So in the boundary value analysis, we will check the boundaries: minimum, minimum minus 1, minimum plus 1, maximum, maximum minus 1, maximum plus 1. 6 parameters, we will cover everything. We no need to pass all the values. So this will also reduce the data, and the same time it will improve the test coverage. So this is boundary value analysis. So here we will test only 6 parameters: minimum, minimum minus 1, minimum plus 1, maximum, maximum minus 1, maximum plus 1. That's it. So along 6 parameters, only 2 cases will fail. So minimum minus 1 means this one will fail, and maximum plus 1, this get criteria will fail, and rest of them should pass. So by considering this kind of techniques, we can prepare the test data. So boundary value analysis, mainly focusing on the boundaries of the value, not exact value, boundaries. I'm talking about boundaries, not the value. Okay. So that is boundary value analysis technique. Okay. So boundary value analysis, we just verify the boundary of the values, and we will consider six parameters. One is minimum, minimum plus 1, minimum minus 1. Similarly, at the maximum boundary. So maximum, maximum plus 1, maximum minus 1. Okay. So these are the 6 parameters we will verify. That's it. That is boundary value analysis technique. Now, let us move on to the another technique called decision table. So, and one more thing, especially equivalence class partitioning and boundary value analysis. These two techniques will be used in input domain testing. So we have some testing type called input domain testing. So what is input domain testing means what? Input domain testing, we will verify the input, whatever we provided in the text box is correct or not. So the value will be verified in the text box, especially text boxes or input fields. Okay, then we will conduct the input domain testing. So the value will be verified, whatever value we are providing into the text box, that value will be verified. So whenever you see the text box where we will apply BVA and ECP techniques to prepare the test data, so the value will be verified in text box or input fields. So here we use ECP and BVA technique. Okay, so here we use ECP and BVA techniques. So in interview, people may ask, what are the input domain testing techniques? So input domain testing techniques, we use equivalence class partitioning and boundary value analysis, which is called as input domain testing. Input domain testing means wherever we have to pass some input, where and all we will perform input domain testing. So where we will use ECP and BVA techniques to prepare the test data. Okay. So the next type of testing is decision table testing. So it is not testing type actually. Don't confuse. These are not testing types. Okay. These are the techniques we use for preparing the test data. Okay. Decision table. So this is also one of the very, very useful technique. And by using these techniques, we can reduce the data. At the same time, we can increase the coverage. So now when we use a decision table, and this is also called as cause effect table. Cause and effect. Cause and effect. Decision table is also called as cause and effect table. And this technique will be used if we have more number of conditions and corresponding actions. See, sometimes you have certain scenarios where you need to verify a lot of conditions. If so and so condition is true, then do this action, or so and so condition is true, then do other action. So based on the conditions, you have to perform different type of actions. In those cases, you have to prepare a different set of data based upon your conditions and actions. So we have to cover all the conditions, at the same time you have to cover all the actions, and for that we have to prepare data. So in that case, we prefer decision table technique. So in the decision table, how we will prepare the data, how we can use this technique. So let me show you one example. So this is my requirement. So let's take an example of transferring money online to an account which is already added and approved. So I have one account which is already added and approved account. So I want to send money to that account. And here there are certain conditions and actions to be performed. So what are the conditions I have to follow here is, so my conditions are, okay, so my conditions are account already approved, account approved. This is one condition. OTP matched. So as soon as whenever you're sending some money, you will get some OPT, right? That OTP should match. That is one condition. And then you should have sufficient money in your account. Okay, so these are the three things you should have if you want to send a money. Okay, you are a sender, you have to send the money to the other people, right? They are receivers. So what is the conditions are? First, your account should be approved, and OTP should be matched, and you should have sufficient money in your account. So these are the conditions should be satisfied. Now, actions to be performed. Based on these conditions, we have to do certain actions. So we have to transfer money, that is an action. Suppose if you don't have money in your account, then immediately it should show the message as insufficient amount. And suppose if your OTP is not valid or not matched, then block the transaction in case of suspicious transaction. Right? These are the actions to be performed based on certain conditions. Now, for this requirement, we have to write test cases. And we have to cover each and every condition at the same time, every action also should be covered. So whenever you see this kind of requirement, like conditions, corresponding actions, then we go for decision table technique. So now I'll show you how we can use this decision table technique to prepare the scenarios. Just a minute. Yeah. Right. So see this particular table. So in the decision table technique, what you will do is whatever conditions we have and actions we have, we will list out in the table. So here you can see, first I provided all the conditions, three conditions I have, again corresponding three actions you have. Sometimes you may have a number of conditions or a number of actions. They may not be equal. So sometimes you have only two conditions and you have five different actions. So first of all, in the particular table, small table, we will put all the conditions and followed by all the actions. Now here, if I just look at 1, 2, 3, all three conditions I have put here. Account already approved, OTP matched, sufficient money in the account. So these are the conditions and followed by different actions. So what is action 1 is transfer money. Action 2 is show message insufficient balance. Action 3 is block the transactions in case of suspicious transaction. So these are the conditions followed by different actions. We will list out everything in the table in proper order. So once you provided conditions and actions, then we have to create multiple columns like this. And each column will be one test case because we need to cover multiple combinations. Okay. So here we will mainly focus on the combinations, different combinations of tests we have to prepare. And we will prepare multiple columns. We use most of the time Excel sheet to prepare this kind of tables. So we will we will add multiple columns like this. Each column is representing test case. So this is one test case, second, third, fourth, and you can add any number of columns depend upon the coverage. Okay. So once you add it, let us check multiple conditions and combinations. Suppose account is already approved, which is true. OTP is also matched. Okay. It is also true. And you also have sufficient account, which is also true. So all three conditions are matched means what? You can transfer the money. So this action to be performed. So this will be one test case. So your account will be approved, OTP match, sufficient balance is enough, and you transfer the money. That should be successful. So that is one test case and combination. And the second test case. In the second test case, account is already approved, true. OTP is also matched, but insufficient money in your account. So sufficient money in your account is false. You don't have sufficient amount. Then what is an action to be performed? You cannot transfer the money here, right? Because you have insufficient money. So show message insufficient amount. You can transfer the money, but what is the outcome you will get? It will come. So show message insufficient amount should be executed. So this is one test case. So account already approved, OTP is also matched. Check you don't have any balance in your account. Then try to send money. In that case, you will get this message. Show message insufficient account. This should be executed. This is the one combination. Now the next combination. Account is already approved, OTP is not matched. You also have sufficient money in the account, but OTP is not matched. And at the time when you send the money, what will happen? Block the transaction because OTP is not matched. So block the transaction in case of suspicious transactions. This is one test case. So you need to mainly focus on different combinations, act condition and corresponding actions. Now the fourth test case. So account is already approved, which is true, but OTP is also not matched. There is no sufficient money. OTP not matched. There is no sufficient money. Then what happens? Again, the last action should be executed. Block the transaction because OTP is also not matched means block the transaction. This is one test case. And only the first one is a valid test case. Rest of three test cases are the invalid or negative test cases. We don't say invalid test case, they are negative test cases. And the last test case is actually invalid test case. Suppose account is not approved. When I say false means account is not approved. Account itself is not approved means there is no chance of OTP match or having the sufficient money, right? So this is an invalid test case. This is an invalid test case. And these three are the negative test cases. And the first one is a valid test case. Okay. So based on this table, we can prepare the test cases by which we can conduct the testing. So here we covered all the combinations. The account is already approved, but OTP is not matched. Sufficient money in the account is not there. Then what is the action should be performed? Similarly, account is already approved, OTP not matched. Then what is action should be performed? Account is matched, OTP is matched, but insufficient money in the account. And what is the action should be performed? So by using this decision table, we can cover each and every combination. Okay. So conditions and action should be there. So whenever you have number of conditions or more number of conditions and corresponding actions, and this technique will be very, very useful to prepare the test data along with the test cases. Now every column is one test case. So for based on this column, we will prepare some tests. Okay, account is already approved, OTP is matched, transfer the money, sufficient amount in the money, and transfer the money. These are the steps to be written, execute. And then what is an expected? Like money transfer should be successful. So this is actual test case which we have to prepare based on the columns. Okay, this will cover each and every combination of the data, condition, corresponding actions. So this is a example of decision table. Now the next technique is state transition. So let me write some notes. Decision table. If we have more number of conditions, corresponding actions, then we use decision table technique. So in interview, people may ask, when you have to use decision table technique, can you give me one example? Then you should able to explain with some example. So draw some picture, take one small requirement like this. I have given one example, right? So take small requirement and try to design the table and explain in proper way. Okay. So this is a decision table. Now state transition. So state transition is also one of the technique which we use for test data designing technique. So let's see what exactly it is. So state transition is a technique. Uh, Basically in this, input will be changes based upon the status. So we will do different navigations or different actions, and accordingly input conditions also will be changed. I'll tell you one example, then you can understand. So this technique allows the tester to test the behavior of application, and the tester can perform this action by entering values input conditions in a sequence manner. And in state transition technique, the testing team provides positive as well as negative input test values for evaluating the system behavior. So first let us understand what is state transition. State transition means what? Changing the state from one to another, changing the condition from one state to another state. So let's see this example. And this is something called a login part. Suppose if you go for an ATM or if you are using internet banking application, How many times password is allowed? Suppose if you enter password wrong, how many times it will allow? Maximum 3 times, right? Even if third time, if you enter password, third time is also you enter is a wrong password, then it will lock or it will block the account, right? So let us take that scenario and see how state transition example works. If I just look at this, I have a small picture. So take an example of login page of an application or some ATM, which locks the username after 3 wrong attempts of password. Okay, this is my requirement or scenario. Now, let us first, we need to check the different states. So when I enter the password first time, when I enter the password first time, it should allow. If it is a correct, it should allow. Okay, it should pass. First time, if a proper password is provided, it should allow and it will give you home page. And here, what is the transition? So we are there in the login page and first attempt, which is valid password, and then home page is displayed. This is one transition, which is one state transition. Now, suppose first attempt it is got failed. Now again, second attempt. In the second attempt, we provided valid password. Then again, home page will display. Suppose if second time also I provided invalid password, then third attempt. In the third attempt, we provided valid password, then home page will display. So in the third attempt, if you provide invalid password, the account will be locked. So this is a state one, and this is a state two, and this is a state three. So each and every attempts we consider as a states: state one, state two, state three. And in every state, we provide some kind of input, valid input and invalid input. So valid and as well as invalid. If I provide valid input for the state, it will go to home page. When I pass invalid input, it will go to the next state. Similarly, if I pass valid input, it will go to home page. If I pass invalid input, then it will go to next state. So by changing the states, we are also providing the valid input and invalid input. So based on this diagram, we will prepare a small table like this, and this will give you more clarity on this. So first we will have all the states. So there are multiple states we have. So even this is also state. Let's say we can call it as a S4 and this is a S5. This is every node is representing the different states. Now we will list out all the states in one column and we will also name them. S1 is a first attempt, S2 is a second attempt, S3 is a third attempt, S4 display the home page, S5 account is locked. So 5 different states we have specified, and then here we prepare some data. Suppose in the state 1, in the first attempt, when I pass the correct password, for example, in this state I pass the correct password, and then in which state we have to go? S4. If I pass the correct password in the state 1, we have to go to S4. So S1 to S4. So if I pass the correct password, then we go to S4. If I pass the incorrect password here, then we go to another state. What is that? Here, S2. That means second state. So if I just look at the first row here, in the first state, if I pass the correct password, then we go to S4 state. That is home page. If I pass the incorrect password in the first attempt, it will go to S2. S2 means what? Second attempt. So this is the one test. Now the second test, second attempt. S2 representing the second attempt. In the second attempt, if we provide the correct password in the second attempt, if I provide the correct password, it will go to S4. So S4. And in the second attempt, if I pass an invalid password, then it will go to S3. That is a third state. This is a one test. Now S3, state 3. In the state 3, third attempt, if I pass the correct password, it will go to S4. So S4. This is valid. In third attempt, in S3, if I pass invalid password, then it will go to S5. That is, account is locked. So this is a state transition, one state to another transition. How it is going to change based upon the input we provided. Based upon the input we provided. When I pass valid input and invalid input, how the state is transferring or how the state is transitioning one step to another step. So that we are going to focus. So this is another technique which we have to use. State transition example. Okay, so if you have multiple navigations and where we have to pass valid as well as invalid data, and then we check whether properly working application under test which is properly working or not. So this is a one of the important technique, state transition technique. So decision table will be used if you have more number of conditions and corresponding actions. And state transition technique will be used if you have a multiple conditions, or not conditions, multiple states. Here we mainly focus on the different states of transactions, like different atoms. Okay. So remember this. And the last technique which we have is error guessing. Error guessing. Okay, this is a very simple, a small technique, and we don't have any something, any conditions, actions, nothing. It is just guessing the error. So when you will able to guess the error, so normally if I give some application, okay, and something is not working, how we will know that whether it is working properly or not? So based upon your guessing, based upon your experience, based upon your analytical skills, right? And this is purely depends upon the tester individual analytical skills. Based upon their experience, they can guess the error. They can guess the error. For example, you have some online application, so where you want to set the products, add them to cart, and then you do payment. Okay, this is the flow. First you need to search the products, add that product to your cart, and go to the cart, and then you do the payment. So this is the action flows. So suppose you don't have any test case or any document, nothing, and I'm searching the product, and after searching the product and adding to the cart, and then there is some payment options are not properly working or payment is got failed, then immediately you guess it, okay, there is an error in the payment process. Or suppose whatever product you selected, when you click on add cart, which is not properly adding to the cart, so immediately you will know that okay, this is an error. And do you refer any documentation or do you refer any other document to to guess this? No, this is just our assumption. This is our just our analytical skills. This is just based upon our experience. We can tell where this is error or not. Okay, this is purely depends on the tester analytical skills and their experience. Okay, so this is error guessing techniques. Whenever you do some testing or actions, you can guess maybe this may be the error or this may be the not error. You should able to judge it, okay, based upon your analytical skills and your experience. That is basically called as error guessing. So error guessing is one of the testing technique used to find the bugs in the software based on the tester's prior experience. So error guessing, we don't follow any specific rules and regulations, nothing. Just we are blindly test the application and check the errors. This is also one of the technique, and it depends upon the purely tester analytical skills and their experience. Okay, and some principles we follow here. Some examples are, let's say, submitting the form without entering a value. So what you will expect? I don't have enter any value in the form, but I'm just click on the submit. So there should be some error message should display, and that is a error we are guessing. We are expecting some error should be there. So that is called a error guessing. Similarly, entering some invalid values in the text boxes. Okay, entering invalid values such as entering alphabets or numeric fields combinations. And what kind of error it is getting? Suppose you have some box and it allows only numbers, but you enter some text or you enter some alphabets, you are expecting some error, right? And similarly, suppose I have a numeric field, there it will allow only numbers, but you have entered some alphabets or special symbols, something like this. So in this case, you are guessing some error, you are expecting some error from the application. So that is called as error guessing. That is called as error guessing. So in every area, we can guess some error. We can pass some invalid data and check the error is coming or not. Okay, that is a error guessing technique. So these are the 6 techniques which we have to use. to prepare the test data or test case design. So equivalence class partitioning, boundary value analysis, decision table testing or decision table is a one of the technique, and state transition and error guessing. So these are the five test design techniques which we have to prepare test cases or test data. And what is the use of these techniques? Which will reduce the data. So this is a main focus we have to, okay, you need to focus more on this. Why we need to go for techniques? If you don't use techniques, you will prepare huge number of data, and they may not cover each and every scenario in testing. Okay, so you have to prepare the data intelligently. So you have minimal test data, at the same time it should cover everything. You should not miss even a small corner scenarios while testing it. For that, we need to prepare different combinations of data. So the main usage of testing techniques is reducing the test data. At the same time, we increase the coverage of testing. So coverage is very, very important in all the cases. As a user, even though I'm a tester, I should always think about the user. So if I give application to the user, what kind of data he may enter? So we have to think in the user perspective, and think all the positive and negative test cases, all the positive and negative scenarios. Okay, that is the main job of tester. Think positive and negative tests in all the cases. Okay, so these are the different techniques which we have. By using these testing techniques, we prepare the test data and test cases. Okay, so guys, have you understood? So this is all about test design techniques. Okay, so these are all test design techniques. So with this, we have covered this part, and in the next session, okay, we are going to start STLC process. This is a very, very important thing. So STLC, software testing life cycle process, and we'll discuss in the next session.